Today we're going to learn how to use the nodes storeName attribute, nameAttribute, and captureAttribute. I will show you different examples to help you to understand better how Geometry Nodes works. So let's see. Okay, let's go to Geometry Nodes, create a new profile. I'm going to close this, and let's bring storeName attribute. As you can see, this node have an input and output of geometry. So that means that this node only works in the middle of this type of wires, the green ones. Because basically what does is to get the information in the middle of some process, for example, between these two nodes. Now, why it's called a storeName attribute? It's called a storeName attribute because basically it stores safe data, information. Which type of data? Attributes. And why it's called name? Because when we store this type of data, attributes, we can give a name. Where? Here. That's why it's called a storeName attribute. Now, to see this, let me open the spreadsheet. And here, in vertex of this geometry, we can see the position. This is an attribute. It has the position of every vertex of this geometry. Now, what we can do is to create a new attribute. Here. How? Giving a name here. So let's try, for example, age. And now that I create a name, it creates an attribute called age. And it appears here. And it says that every vertex have 0 values. Why? Because the input is 0. So basically, we are storing a new attribute that we created with the name age with the value 0. And we can see it here in the spreadsheet. Now, if I change this, as you can see, it's going to update this column. As you can see. Now, this is a float. That means that this diamond, that is gray, is a type of data, a value, a float. However, we can change the type of attribute that we are using. Clicking here, as you can see, if I make it smaller, this list is data type. That means the type of data that we are storing. If I want to have full numbers, I can select integer. And now this color change, and this only have full numbers, no more decimals. So I can select, for example, vector, and now we have a vector, we have a different color, and we have 3 columns. Because a vector, remember, is 3 axes, x, y, and z. So I can say, look, 1, 2, and 3. This is the data that I want to store it when I select a vector. So you can see, we can store any type of data. You have more data types here, but the most common are float, integer, and vector. Okay, now, something important. Let me select, for example, float, and select 10. If I use another storeName attribute here, and I use the same name, for example, age, now, as you can see, it doesn't say 10. So if I mute this, it says 10. As you can see, it's the same. However, if I use the same name attribute, so the same word, the value that matters is the last one. So that's why now it says 0. If I select, for example, 20, it will say 20. What I mean is that this value now doesn't matter. I can try to change this. That doesn't matter. Why? Because this one updates, override this value, the previous value. So the important point is that if you use the same word, the value that matters is the last one. However, if I change this word, for example, I write money, now, as you can see, we have 2 different attributes. This one is the previous one, and this one, this one. For example, I can select integer, and now you can see better. So, if you use the same word, the last node with the word will update the previous nodes with the same word. This is really important to understand. Now, instead of writing you the value, what we can do, for example, is to add a float. For example, a random value. This node is a float with random numbers with a field. That means that if we connect this here, now is storing these random values between 0 and 1. And this type of lines that now have dashes, that means that is storing more than one value, more than one. And we can see it here. That's why now we have different numbers between 0 and 1. But maybe I want to say between 0 and 10, as you can see. Or I can change the seed. And we can do the same here. For example, we can use random value, but in integer. And now it's going to store a list of random values between 0 and 100. And you can see it here. If I change the seed, you can see that basically is storing random values. Okay, so now you understand how this works. Now the main point, why we want to use this type of nodes. We want to use this type of nodes because usually when we add a lot of nodes of geometry, we lose some information. So thanks to this, we can keep this information and use it later in the process. Okay, so here I have an icosphere, as you can see, thanks to this node. And basically what I want is to use the normals. Remember, the normals are the perpendicular lines that each geometry has, that comes from the faces and the vertex, the points. And I want to use this attribute, because this is an attribute, a vector, a direction, to later add UV spheres. For example, a UV sphere in each corner, each point, and I want to move it in the normal direction. So, to do all this, what I have to do is to use the node normal, because this node have the information of these lines, this vector, this attribute. Okay, so first of all, let's add UV spheres in each point, in each vertex, thanks to instance on points. So let's add on the points, on vertex, the instance like UV sphere. Let's make it smaller. And now, as you can see, if we do a preview with Ctrl-Shift left click, we can see that in each point, each vertex, we have a UV sphere. Okay. Now, what I want, remember, is to create this animation that each UV sphere is going in the normal direction, outwards. So, to do this, we need to use set position. And thanks to set position, thanks to offset, we can move, displace all the UV spheres in one single axis or all the axes at the same time. However, as you can see, all the instance UV spheres are following the same direction. So I don't want that. What I want is that each instance, each UV sphere is following the normal direction. So different directions. So to do this, we need to use the normal. We need to use this vector with this vector. If we connect this directly here, we don't have any control. So what we have to do is to add in the middle a vector math. For example, in scale. That basically is multiplying this vector. So thanks to this, we can scale the normal. And in theory, we can push this instance in the normal direction, in these arrows that we saw before. So let's try it. And as you can see, it doesn't work. Why? Why it doesn't work? Why it's not using the normal attribute of this object? This doesn't work because when we add this here, we converted the geometry. So basically, we had a geometry with a mesh, vertices, edges, faces, where this geometry has the information of the normals, but after adding this, we converted this information to instance, as you can see in the output, in 12 instance. So in this process, we lost the normal of this object. That's why now it doesn't work, because it's like being empty. So how we can solve this problem? How we can say, hey, can you move this instance in the normal of this object? To do this, we need to use a store name attribute to store the normal and use it later to not lose the information. So let's bring a store name attribute, add it before we lose the normal. Let's disconnect this here. And what we want to store? The normal. What is a normal? Is a vector. So let's select vector. And now, instead of us giving a value, we want to store this because this is a field and each vector have a different direction. That's why we see this type of wire. Now we need to give a name. So let's write, for example, normal. We can choose if we want the normals of the point, edges, faces, or any other part of the geometry. I'm going to leave it in points. And now that we are storing this information, we can use it later. For example, here. But how we do that? To use this information, we need to use the partner of this node called name attribute. So basically, it's the same name except store. And thanks to this, we can write the same word. We can write it or select it in the list. And if we change the name from the list, like I did before, it will change automatically the type of output, like vector. We can do it manually, as you can see. But if you select it from the list, this list, it will change. So now we can use this and connect it here. So thanks to this, we are using the normal before losing after using this node. So if I connect this here, as you can see right now, let me select one again. This is working. It's using the normals of the original geometry. That's how we use store name attribute and its partner, name attribute. So basically, this node is like if this is Wi-Fi. This is the modem, and this is your computer, your phone, and to access to this information, we need to use the same word, the same password. Once you use the same password, you are accessing to this information. So the next node can read this information. This is how it works. Now there is an alternative of a store name attribute that is like the version of not using Wi-Fi. And this alternative is capture attribute that basically is like the same but with a Wi-Fi. What I mean? So here the only thing you have to do is to select the domain. I'm going to select point, and instead of selecting the data type and give the value, we directly connect here the input. And now it gives you an output, and we can drag this and connect directly the wire here. And it's the same. So it's like not using Wi-Fi, using a wire. So it's similar, it's like the same. However, it's not so clean, as you can see, because we have the wires in the middle. And if you want to reuse this information later, you will have more wires. That's why almost everyone use a store name attribute, because it's cleaner. So that's the difference between a store name attribute and capture attribute. In one node, you give a name, and you can use with another node this name, this password to access to the information. And when we use capture attribute, we don't need any password, any name, because we use a wire to connect it directly to another input, another node. Okay, now let's see another example how we can use a store name attribute. For example, let's use a curve like a spiral or any curve. I have this curve, and let's give a mesh. So let's use curve to mesh, and let's use circle curve to convert it to a mesh. Let's select fill caps and make it smaller. So I have this curve. Let's select the material view. And basically what I want right now is to apply a gradient to this curve. And what I want is that at the end have a color and at the start have a different color. So the gradient, it will change along this curve. Okay, so how we can do that? First of all, we need to add here set material and select one material. let's use the default material. And now what we have to do is to open the shade editor. So let's go to the shade editor. Here we have the material. Let's check if it works. Okay. So to apply a gradient, what we have to do is to use a gradient and in the middle use a color ramp. So let's connect this here. And now as you can see, it's applying a gradient, but from here to here, as you can see, if I move this. And I don't want that. I want to follow the direction of the curve. So how we can do that? To do this, we need the factor. Remember, the factor is the information from the start to the end of any curve. So we need to send here the factor of this curve. And here we don't have any node to access directly to the factor of this curve. However, in geometry nodes, we have this node called a spline parameter that have the factor, the information from the start and the end of any curve. So maybe what we can do is to send this information to the shade editor. So from geometry nodes to the shade editor. And this is possible. So how we do that? First of all, what we have to do is to store this factor. Where? Here or here? We need to do it when it's a curve. So here, in this process, because here it's a mesh. So here we need to use a store name attribute. And now what we want is to select float because this is a float and use this attribute, this field. And let's give a name. Let's make it easy, factor. And now thanks to this, we are storing this information, as we know. And what we can do is to send this information to the shade editor, like if it's Wi-Fi. So here we have a problem. We don't have name attribute, but we have attribute. So attribute node is the node to read like this type of data, this type of password that we store here. So this is an attribute called factor. So the only thing we have to do is to write the same word that we created to create this attribute, factor. And now, if we connect this here, we can use this for factor. As you can see, it's working. Thanks to this, it's reading the factor of this line. So as you can see, now this is working perfectly. The gradient is following the direction of the curve, as you can see. Because thanks to a store name attribute, we are storing this attribute and we are sending this information to the shade editor, and thanks to this node, we can read this information. Another way to do it that I was doing at the beginning, and a lot of people do it at the beginning, is instead of using a store name attribute, what you can do is to, for example, let's open this, and what I'm going to do is to get the factor. So let's delete this and use capture attribute, connect the factor here, and now connect this to the input of the group output. And you will notice that here appears output attribute. So now if we write a name here, for example factor, like before, it's going to work. So basically, connecting this here, thanks to capture attribute, because we need to capture this before it's being converted to mesh, you cannot directly connect this here, if not, it's not going to work, as you can see. It's like the old way to send information from geometry nodes to the shade editor. But as you can see, it's a bit ugly and annoying, and it's more steps. So it's easier to just use a store name attribute. It's cleaner, you don't have any wires in the middle, and it works perfectly. Once you understand how this works, you can use it in any project to send information from one part of the process to after any conversion, like we saw before, or from geometry nodes to the shape editor. Okay, so here I have another example. We have a grid that I create thanks to this node, and I have an external object, a UV sphere. And basically what I want is that when this UV sphere is getting really close to this grid, the color of this grid, of this plane, change based in the distance, in the proximity. So here I can get the information of this object. Let's select relative, and thanks to geometry proximity, if we connect this here, we can get the distance between this object and this object. So I want to change the color based in the distance. So what I have to do is to use something here in the shape editor. So let's store this attribute, the distance. Let's connect it here. Let's leave it in float because it's a float, as you can see. And let's give a name. For example, distance or proximity. Let's call it proximity. And now I can send this information here. So let's come back here and let's write the password, proximity. And now if we move this, in theory, it should work, as you can see. Let's add more vertices. And now something is happening because it's reading this information, the distance. We can delete this, we don't need it. We can directly connect this here. And as you can see, we can now play with this to create this effect. And if you want to have more control, then what we have to do is to map range these values with map range. If you don't know how to use this node, I recommend you to watch my tutorial about how to use map range. So basically, thanks to this, we are controlling the distance of reaction. If I increase this, I'm saying to increase the distance of the color, as you can see, 2 meters. So this is another example how to use a store name attribute to get the distance, the proximity between 2 objects, to send this distance to the shape editor and later do something with this information. For example, changing the colors. So I hope now you understand better how to use a store name attribute, how to send information from geometry nodes to the shape editor, how to use capture attribute. And if you want to learn more techniques how to use this node, I recommend you to watch my tutorials about simulation nodes and other tutorials that I have in this channel. So if you like this video, please give a like, subscribe, and remember you can donate this project and many more than 100 on my Patreon. And see you in the next video.